In this question it says, consider the following balanced chemical equation. In the first 20 seconds of the reaction, the concentration of H plus falls from 0.6 molar to 0.3 molar, and we're asked for the average rate of this reaction. So before we do this exact example, I want to remind us of the overall equation that we want to use here. So if we think of the reaction A to the A, aqueous or gas, plus B to the B, yields C to the C, plus D to the D, the rate is equal to 1 over negative 1 over little a times the change in concentration of A over the change in time. That'll give us the average rate, which is also equal to negative 1 over B times the change in concentration of B over change in time. So we're going to lose the reactants. So it's negative with respect to A and B because they're reactants. We also have to take into account the stoichiometric coefficient, small a and small b, because if we take two of these, the rate at which we lose them is going to be half as fast. If we need 10 of these, the rate of the reaction will be 1/10 as fast because 10 of them causes a reaction to occur. Now for the products, it's the same thing except it's not negative. So now it's positive 1 over C times the change in concentration of C over change in time, and 1 over D times the change in concentration of D over change in time. So don't forget that if you put a chemical in brackets, it means concentration of, usually in molarity, in this case in molarity, and this is basically the general form of this equation. Now remember, all of these things are equal to each other, and we're going to use this equation as we solve these problems. So in the first case, it asks us for what is the average rate of this reaction, and we're given the change in concentration of H plus, which is a reactant, and there's two H plus used. So let's look at this. Essentially what we want is rate equals negative 1 over 2, because there's two H pluses, times the change in concentration of H plus over the change in time. Now it says in the first 20 seconds, so it gives us the change in time. We don't need to actually find that. If we did need to actually find that, it'd be T final minus T initial. But for the concentration in H plus, it doesn't actually give that to us. Here we have the initial and the final concentration. So what we need to do in order to solve this is we need to take the concentration of H plus final minus the concentration of H plus initial in order to find the change in concentration of H plus. So in this case, what we need to do is still negative 1 over 2. We need to take the final H plus concentration, 0.3800 molar, minus the initial H plus concentration, 0.6000 molar, and we need to divide that all by the change in time, which is 20 seconds. And when you do this math, you find that it's 5.500 times 10 to the minus 3 molar per second. So that gives us the rate of change for this particular reaction. Now part B says, what is the rate of change of I minus during this time period? Well, remember, all of these things are related to each other. So the rate is related to both H plus and I minus. So in this case, the rate equals negative 1 over 3 for I minus times the change in concentration of I minus over the change in time. And in this case, we're looking for the rate of change. So this whole thing is essentially the variable. The whole expression is the variable. This is what we're trying to solve for. Well, we know the rate, we can plug in. The rate we just found. So 5.500 times 10 to the minus 3 molar per second equals negative 1 over 3 times the change in concentration of I minus over change in time. So we want to multiply both sides. Multiply by negative 3, multiply by negative 3 to get rid of the third on this side, and basically to just get rid of the third on this side, and that will get rid of it. And when we do this, we find that the change in concentration of I minus with respect to time, the change in time, is negative 1.650 times 10 to the minus 2 molar per second. Mathematically, you could divide both sides by 1/3 or multiply negative 1/3 or multiply both sides by negative 3 and you'll get the same answer. This will cancel out. So this is basically how we can use this general form in order to solve these problems.